All right, you guys, we're going to go ahead and do 9.7 today. We are skipping 9.6. So just be happy that you're in my class because I am really just trying to focus on what you need for next year for calculus. So most of the time, I'll make sure that I communicate with your calculus teacher for next year or even your pre-cal honors teacher for next year and let them know what we've skipped. But I'm really trying to focus on what's most important for you to be successful next year, okay? All right, so I am going to look here at 9.7. All right, so we are going to be working with inverse trig functions. So inverse trig functions are going to occur with either this arc sign, or they could also write it as sine inverse of x. So either one means the same thing, okay? And what's special about your inverses, and most importantly, is that whatever this x is here is actually going to be your answer that you would find usually on a unit circle or by drawing a triangle. So for example, arc sine of something would be like 1/2, square root of 3 over 2, square root of 2 over 2, 0 or 1. Those are all values that we could locate on a unit circle. So my answer to sine inverse of something like, 0 would be where on the unit circle is sine 0. That's what I'm trying to find. And my answer would be the degree or radian. All right. You will notice that everywhere on the unit circle, I've mentioned this before, there are two locations on the unit circle for each trig function, right? There are two places on the unit circle where sine is equal to 0. There are two places on the unit circle where sine is 1/2 at that point, right? So you'll notice that each of these have a range, which means that they only want you to give the solutions in two quadrants. Now, the tricky thing is in previous problems that we've been given, they've written this next to the question. Well, when this particular question comes up on a test, you're not given the quadrants that it falls in because that's part of what they're testing. So the main thing that you need to remember is that all the trig functions are in quadrant 1 and 4. The only one that's in 1 and 2 is cosine. Okay? And this will make more sense probably as we do some problems. Now, another thing I want to mention is if you got completely lost in 9.5, that is 100% normal, okay? That doesn't mean blow off the rest of the unit. That just means simply that you're struggling with graphing, which is normal. So make sure you're attending the tutoring days. Make sure you're coming to the Zoom sessions that I offer because I am going to make sure that I try to clarify that stuff for you. Make sure you're filling out the homework questions. I mean, I'm working about 3 hours each time and just preparing your guys' materials and your PowerPoint for every session that I give. So I'm putting in a lot of work to try to make sure that I explain everything as clearly as possible for you because I know this is much different than seeing you in person. But I want to make sure you're also prepared for next year. All right, so just keep that in mind. The next piece here is actually a really easy part. So, and I was going to tell you, if you struggled with 9.5, it's okay. You don't need any of 9.5 to be successful in today. And this section should be like a breath of fresh air. It's pretty simple, okay? It looks complicated already because we got extra letters going on in math, but it's not too bad. All right, for these inverse properties of trig, it's mainly just looking at the pattern, okay? So if I have sine here and I have arc sine, basically when you have them together, they cancel each other out and your answer is just the x. Same thing goes if it's switched. If I have arc sine and then my sine on the inside, my answer is still just the y. And you can kind of memorize this for all of them because you'll notice that that pattern continues for cosine and that pattern continues for tangents. You will notice I don't see it for cosecant, secant, and cotangent because it's just not as popular as it is for the original three. These types of problems with inverses usually happen with sine, cosine, and tangent. Okay, I am noticing that I am going to need a unit circle. So if you don't have a unit circle, make sure you guys grab one, maybe have it next to you. Oh, I guess oh, there it was. was going to say, I think I lost mine. It'd be faster if I just click it from here instead of shifting it down. So maybe have a unit circle out next to you in order to complete these problems, okay? I'm just going to move this guy over here. All right, so like I said, if you sucked at 9.5, totally normal, all right? But doesn't mean you can't be successful in 9.7. You got this, okay? For 9.7, watch how easy this is, okay? All I need to know, I see arc sine. So in my head, arc sine, automatically, the part I need to have memorized is that this is only in quadrant 1 and quadrant 4. That's what was written up here. For arc sine, it is in quadrant 1 and quadrant 4. My sine, another thing you need to have memorized. You should have this memorized by now if you've been doing your homework. That when we're looking at the points, the x value is my cosine, the y value is my sine. So to find arc sine of square root of 2 over 2, that means I'm going to look at all of my sine values in quadrant 1 and 4 right here, and I'm going to see which angle has sine, my y value, as square root of 2 over 2. So I'm looking at my y values, and sure enough, I see it right here at pi over 4. So the solution to this is pi over 4. Now, how did I know to write it in radians and not degrees? If they don't specify which one to write it in, always go with radians. It's really strange, but radians are more popular than degrees are. So, and it also says without a calculator. So that tells me that if I plugged this into the calculator, I would get a decimal. I can't have that. I want to have it in radians without a calculator. Okay, so you're going to write your answers in radians. You'll notice as well, all of these ranges and everything, look at everything is in radians. I don't see any Celsius or degrees going on. So that means write everything in radians, okay? For the next one, we're going to go ahead and use our calculator and evaluate this expression. So I'm going to teach you guys how to plug in an inverse function. So remember, I just quickly noted that you can have arc cosine, or you could have cosine inverse of negative 1/3. These two things mean the exact same thing. So pull up your calculator or take out your calculator. And this is going to be an evaluating question. So I'm going to go ahead and go to the home button. And I'm going to want to have my answers in terms of radians. So remember, you want to make sure that you are in terms of radians here, which means I have the little pi symbol. Uh-oh. I was trying to minimize it. I messed it up. Okay, so I am on the home screen. Okay, mine just looks a little different because it's side by side, but just watch what I press over here. So again, I went home to calculate. I'm making sure that my degrees is correct. It's not in degrees, it's in radians. Remember to switch it between the two. It's right here in that menu. We look good there. Okay, and I am going to go ahead. The question was, there we go. The question was cosine inverse of negative 1/3. So look at your sine, cosine, and tangent button, and you'll notice on your cosine, sine, and tangent button in blue is a sine, a cosine, a tangent. That A represents arc. So in order to access that, I have to click the shift button, and in this case, cosine. Nothing's popping up, so I'm going to make sure my cursor is here. So let me try that again. Shift, arc, cosine, and then negative, remembering that we're using our negative here and not the minus sign. That will give you an error each time. 1 divided by 3, and I'm going to hit enter. And it says round your results to 2 decimal places. So if I look at that solution again, I'm going to have 1.91 as my solution. So my answer is 1.91. So why do you think, if you look at the questions, these two are asking the same thing, but one of them was without a calculator and one of them was with. So I want you to focus in on the actual question that they were asking about. When it was without a calculator, square root of 2 over 2 was an answer that's on the unit circle, right? That's on there. If I was trying to do this problem without a calculator, negative 1/3 for cosine never shows up as a value. So there's no way that I can find this answer without a calculator. So this is an example of definitely a calculator question because negative 1/3 is not a value on my unit circle. So you absolutely have to use a calculator for those questions. All right, almost done. For example 3, use the properties of inverse trig functions to evaluate the expression. I told you guys these ones were super easy. It's using this theorem right here, or property, that whenever you have the function and its inverse together, that the answer is just going to be whatever that value is, whatever the number is. So in this case, I have sine and I have arc sine. So they basically cancel each other out, and I'm just going to have the answer there, which is negative 0.2. And that would be my solution. I do not need a calculator. Another hint is use your calculator the least amount as possible, right, you guys? All right, for our last example here, I have arc tangent of negative 5 over 12, and I'm asked to find the cosecant of that. So this is oftentimes a popular question as well. It's a little bit tricky. So I'm going to use order of operations. Please excuse my dear Aunt Sally, and I'm starting on the inside where the parentheses are. Now, it doesn't say anything about using a calculator. And in fact, if I use a calculator, I'm probably going to get the wrong answer here. So don't use a calculator unless it specifies. So if I look at negative 5 over 12, there's no way that's a solution that's on the unit circle. So I'm going to start first of all by remembering tangent is in which two quadrants? Inverse tangent is this last one here. It's in quadrants 1 and 4. So we're going to review quite a few things, properties that you need to have memorized in order to solve this question. So first and foremost, my triangle needs to be in one of these two quadrants. And this is telling me that my tangent of whatever angle we're trying to find is negative 5 over 12. That is how you are interpreting an arc tangent. And theta we're trying to find. So the next thing that you need to remember from a previous lesson is all students take calculus. And these letters represent where the trig function is positive. So A means that all trig functions are positive in quadrant 1. And C means that only cosine is positive in quadrant 4. I don't care about the other two because my answer can only be in quadrant 1 or 4. So what I want to know is, out of these two quadrants, 1 and 4, where is tangent negative at? Is it negative in quadrant 1 or is it negative in quadrant 4? Well, if I put it in quadrant 1, this A represents all functions that are positive. That means tangent would have to be positive for quadrant 1. So since I know that's not going to work, then I have to draw it in quadrant 4. I draw my line, and I'm always going to attach it to the x-axis, creating this triangle. Okay? So a lot of sections are coming together in this section in particular, in this problem, sorry. The next thing that I need to remember is TOA. I need to know, in terms of opposite, adjacent, and hypotenuse, what is this 5 over 12 representing? So tangent is TOA, right? So this is opposite over adjacent. So here's my angle, always at the origin. Opposite of that would be 5, and adjacent would be right next to it, would be 12. Now you'll notice I didn't put the negative on this yet, because the negative could belong to the 5 or it could belong to the 12. So you have to think about it. Right here, my 12 is representing the distance on this leg of the triangle, which happens to fall on the x-axis. Anything on this side of the x-axis is positive. The 5 represents the distance on this leg of the triangle, which is parallel to the y-axis. So in this case, this one would go down 5. Okay? So that's the one that has to be negative. Now that I've drawn the triangle, I can find any trig function, sine, cosine, tangent, anything at all I could figure out. And that's what they're asking you to do here. So I've drawn the triangle based off of the arctangent information given. And now this cosecant is the actual question. They want me to find the cosecant of this triangle, which is a question that you guys had way back at the beginning of the chapter. So let's remember, cosecant is the reciprocal of which original trig function? Cosecant is the same as the reciprocal of 1 over sine. So if I can find the sine of that triangle, then I can just flip it and that will give me the cosecant. So sine is opposite over hypotenuse, right? So I'm looking at my triangle. I have the opposite. The opposite is -5, but I don't have the hypotenuse. So how do we find the hypotenuse? The hypotenuse is found by using Pythagorean theorem. So in this case, I have -5 squared plus 12 squared equals t squared. So that's 25 plus 144. That's going to be 169, right? So C is going to be 13 because the square root of 169 is 13. So my hypotenuse would be 13. Hypotenuse is always positive regardless of which quadrant it falls in. So my hypotenuse is positive. This is not the answer. The solution is the cosecant. So the solution would be flipping this. So the solution would be -13 over 5. Now I know that question is a lot, but I will be honest with you guys. This is a very popular calculus and pre-cal question because it's testing 3 or 4 different theorems in one problem. These are the types of problems, like example 4, that you can expect to be all throughout calculus. Now, also keep in mind that you're given this question and you may not even be working in trig functions at the time. You're expected to remember all of these different properties that I just went over in this one problem off the top of your head at any time next year. So please keep that in mind. This is a good question that kind of involves a lot of different properties that we've learned in this unit. All right, your homework is going to be number 6 through 38, every other even, and then 50 through 62, every other even. All right, have a good day.